Okay, here we have a true mixture problem. It's not about distance, it's not about interest, it's just a true blending of two things. So Kara makes a trip to the bakery to buy cupcakes for her brother's birthday party. She spends $50.25 on two different kinds of cupcakes. The simple ones cost $1.75 each, but the fancy ones cost $3 each. How many of each kind does she buy if she gets 23 cupcakes altogether? All right, a pure mixture problem is a great problem for the box. So I'm going to draw my box. It's actually, well, that's a little too close together. It's actually a combination of 9 boxes. And so here are my 9 boxes. These need to be a little bit bigger. Okay, now for my 9 boxes, I like to call my middle column of boxes my rate column. A rate is a combination of units, a fractional set of units. For example, a percent, or dollars per pound, or dollars per dozen, something like that. This is my amount column, and that's just what it says. It's how much of each do you have? And then I like to call my last column my final value column. All right, so in this problem, the question is about amounts, okay? Now I'm mixing simple cupcakes and fancy cupcakes. And I don't know how many of each that I buy. In fact, that's the question. How many of each kind does she buy? So I could say that I buy X amount of this kind. But now I do know, and I could say that this is Y, but I do know that we buy 23 altogether. 23 is the amount of the mixture. So this last row here is my mixture row. So I know that I buy 23 altogether. If X of them are simple, then the leftovers, or 23 minus X, are the fancy. One thing that's important here is that these two boxes have to add to equal this box. So if you choose to call this X and call this Y, then you will have an equation X plus Y equals 23, in addition to the main equation that represents the problem. But if I go ahead and just solve this equation for Y, then I get that Y is 23 minus X. And that's what I like to do. Go ahead and put 23 minus X in that box. Either thing works, but just remember that these two boxes have to add up to equal the third. Now the rate box is, in this case, it's a number, it's $1 per cupcake. So the amount column tells me how many cupcakes I buy, and the rate tells me how many dollars per cupcake that I spend. I like to put my units for the columns above the columns. So dollars per cupcake, well, the simple ones cost $1.75 each. And the fancy ones cost $3 each. Okay, now in the mixture problems, sometimes this third box has meaning to the problem and sometimes it doesn't. In this case, this third box would be how much on average would each cupcake cost for the mixture? Well, I'm not interested in that. The problem isn't interested in that. We don't have another dollar per cupcake figure in the problem, so I'm going to X that box out. It's just not needed. Okay, the beauty of this box is that I fill in this last column by multiplying the first two columns. So I multiply across X times 1.75, so I get 1.75X. You multiply this box times this box to equal this box. So when I multiply across in the top row, I get that. When I multiply across in the bottom row, I get this. Now I can leave off my zeros here. So I get 3 times 23 minus X. Okay, I choose to write this way instead of doing the math now, so that if I have a problem later, my answer's not working out, I've got to find my mistake. It's so much easier to come back and check my original setup if I don't do any of the math in the original setup. So it's easier to spot that if I just leave this like here. I'll do the math in the equation. Okay, now obviously I can't multiply here to get this number, but this is my final value. If you multiply cupcakes times dollars per cupcake, the cupcakes cancel and you just get dollars. So these are actually dollars right here. All right, well, the total dollar figure for what I spend for the mixture, remember this is my mixture row, the total dollar figure, the final value of that is 50.25. Now the beauty of the box method is if you can get this filled in correctly, your work's done for you because your equation comes off of this last column of boxes. This box, the first box, plus the second box, always equals the third box. So when I write my equation to represent the problem, I've got 1.75x plus 3 times 23 minus x equals 50.25. That's my equation. Now I'm going to solve this equation. 1.75x plus 69 minus 3x equals 50.25. All right, now when I combine like terms, then I've got minus 1.25x plus 69 equals 50.25. And when I move the 69 over, then I have negative 1.25x equals, now of course you've got to reverse this to subtract, but I get negative 18.75. Okay, now I am not using a calculator right now, so I'm going to rewrite that a little differently. I'm going to do this in fractions because 0.25 is a fourth, 0.75 is 3/4. So I can make this negative 1 5/4 x, and I can make this negative 18 3/4. Now we never do math in mixed numbers. We always do it in improper fractions. So, sorry, negative 1 1/4. So this is going to become negative 5/4. And this is going to become, let's see, 75, negative 75/4. Now when I solve this equation, I'm going to multiply by the reciprocal. So I'm multiplying this side by negative 4/5. Wanting to say and do things backward here. And negative 4/5 on this side. Okay, of course all of this turns into 1. So I have 1 times x, or just x, equals, now over here I can cancel my 4's. My negative signs turn into a positive, and then 5 goes into 75 15 times. So x equals 15. Now let's remember what x stood for in the problem. In my box you can tell that x represents the amount of the simple cupcakes. All right, now the question is, how many of each does she buy? Well, she buys apparently 15 of the simple, which means the fancy, she buys 23 minus 15, so 15 of the simple, and then 23 minus 15 equals 8, so she buys 8 fancy cupcakes. And this answers the question.